ID of our CEO. So now let's run it and see it break. We like to break things. There we go. Statement terminated. The maximum recursion of 100 has been exhausted. So we have proven that we can max out recursion. So that's it. I've got a link right here, and again, I'll make this code, and the link's available after the session sometime today. So there's more on recursive CTE performance at, I'm not even going to try to pronounce this name, his blog. I'm going to assume it's a him. All right, let's move right along to the next little bit. Okay, here I'm getting all happy, right? Over and partition by have to be, I don't know if they're my absolute favorite, but they're pretty close to my favorite improvement in SQL over the last few years. And yes, I know that they were introduced in 05, and I'm okay with that. Let's talk about it. So this is the same statement that we used back in our discussion about select statements and logical order, right? We're getting in AdventureWorks, we're getting product and category information and some aggregates. And that's, let's go ahead and run it. And that really is beautiful. You know, we've got our color, we've got our category over here, and we've got some nice aggregate information. Well, what if I'm interested in seeing the detail for this category? I want to see those 3 items in that category, but I also want the aggregate information. I want to know, you know, I want to see all of this plus the name of this crankset, and then again and then again. Well, we do that with the use of over and partition. Now I'm going to read straight out of VOL here because sometimes they get it just poetically right. Over allows you to add aggregate columns within a query without using a group by. It's as simple as that. For this query right here, we've taken out our group by completely. So this is actually a query on products and at the detail level. And we've also included aggregate information, which over and partition by allows us to have. Hang on, my cursor's going crazy. There we go. Let's go ahead and run this. See, this is, let's go down to cranksets because that's what I was talking about before. There we go. This is exactly what I wanted. I wanted the color, the category, the item count, min, max, average, and then the detailed information, the name and product number for each one within those, within that group. And that's actually absolutely beautiful. Let's talk about how we did it. Now, over says I want to apply this aggregate function. In this case, we're looking at count. I want to apply this aggregate function over some set of the rows coming back in this query. If I leave it blank, like I have down here, and look at the second query. Let's run it. Over blank means I want to see the aggregate for the entire table. So how many items do we have? Oh, I didn't do count. Okay, fine. What's the minimum cost in the entire table? In the entire row set I'm getting back, I mean? It's $8.99. Now, that can be extremely useful, but it's, I think, much more useful to be able to say, okay, well, that's great, but jumping back up to this first query, what about the count just within, like I had in our first query above, the count within the group, category, and color? Well, let's do this. Let's run it. And we saw this before. So say for cranksets, I'm able to say, all right, I want the count over this, where did the top level go? There we go. This group right here, these 3 guys are within the category, within the partition, I should say the right word, of category, crankset, and color equals black. So over partition by color and category, that's the grouping, that's the partition that I want to apply this aggregate to. And I'm kind of belaboring the point a little bit, and sorry if you're like, I get it, I got it 5 minutes ago. But it's one of those things that can take you a little while to grasp, I think. But we'll move on. Let's go ahead and jump down. All right, and one more note about over and partition by here is that just like group by, order and partition by does take null into account. It's not a special case of like union where, oh, well, you know, nulls are excluded. So here's a regular group by, which includes our color is null, and then here's our over and partition by, and you can see that it does deal with color equals null. All right. The next coolest thing about over and partition by is ranking. Now today I'm only going over row number, but you really should dive into BOL and take a look at tile and end tile and all that great stuff. There's more to be done. But today I wanted to talk about row number. So one of the things I've been irritated with for years is the inability to easily get a row number returned along with a result set. I mean, you've got the identity function, but that only works if you're selecting into a new table. And that's not always what I'm doing. And I don't want to have to go out of my way to create a temp table just so I can Row number with over and partition by solves that. Let's go ahead and take a look at that. So select row number over SC name is our category. So let's take a look. Count over partition by. Give me a moment to remember what I'm doing. 1, 2, 3, 4, 5, 6. I think this is ordering by the entire table.
Hi, Jen.
Right. Yeah.
Nancy interrupting. Just had a few notes from some attendees that it's taking a while for their screens to catch up to what you're doing. Okay. So maybe if we could try to slow it down for the attendees.
Sure.
Somehow if you can.
I'll see what I can do, or at least narrate what it is I'm doing. So
yeah, okay.
Yeah, so they know what they're missing. Boy, that's going to be a lot of fun.
Yeah.
Yeah, sorry about that, guys. I know there's a big lag, but this presentation is entirely demos, and that does have a lag to it. But I will describe. We have select row underscore number over, and then without a partition, it just says over order by SC name. That gives us just a row number with over, the row numbering for the entire table. You've got a column that's 1, 2, 3, 4, 5 for the entire table. If you want to do like we did before and apply that just within groups, so that say crank sets are ordered 1, 2, 3, and then the next group starts over 1, 2, 3, 4, then you would say row number over, and I'll go ahead and type this in, partition by SC name, and then order by. And we're going to run that real quick. And rank number, because, oh, that's right, because we're ordering by only category and not color. Oh, well, that's why they tell you not to type in demos. But yeah, you can row number, just like you applied the aggregate within groups, you can apply the row number just within groups. Oh, here I am typing, and I've conveniently provided myself with that code just below. So we say select row number over partition by SC name, which is our category, and then order by list price. That gives us our rank number within the group. Okay, I'm going to scroll down, and then I'm going to talk for a bit. I'm going to run this and talk for a bit, and hopefully everyone will be able to catch up. So we want to find the least expensive item in each category. Now that we've ordered within each category, let's find the least expensive item. Let's find the least expensive crank set, least expensive helmet, and so forth. Well, that's easy enough to do if we take that exact same query we just had, where we ranked by row number within category, and use that as a CTE. Ah, you like how this all kind of joins together in the end? So that's our CTE. Our ranked by number, ranked by price rather, within category. And from that, our main select statement just says pull everything out of that CTE where rank number equals 1, because rank number equals 1 is always going to be the cheapest item in that group. So we have this wonderful list, and again, I'm going to scroll down and skip ahead and speak ahead while we're doing this. So we've got that, and which is absolutely fabulous. So wait a minute, now it looks like we're kind of putting together maybe a special deal for the salespeople to offer to customers, right? Like call it a Thrifty Savers package, where you get one of everything we offer, but it's the cheapest price. Well, one of the great things about specials is not just that, hey, we'll put everything in a package for you, but we're going to discount it, right? Well, it would be really useful to know then how much that package would cost. How much would it cost if you ordered absolutely everything, the cheapest one of everything? And you can get the answer to that by doing a sum of list price over the entire row set you're getting back. and that's our total cost. And further, get the sum of the standard cost over the whole table to see what it is that I, as the company, pay for it. So there you go. We've got all of our details. We've got all of our cheapest items, and then the standard cost versus total cost, and we can make a business decision at how much to discount the total cost for the customer and still make a decent profit. Wow, it looks like we actually got kind of real world on this after all, didn't we? Didn't mean to do that, sorry. Let's go ahead and move on. Ooh, 4XML. This is a fun one. I'm going to skim through this one just a little bit because we're starting to run short on time, and I don't want to skip out on some of the later stuff. 4XML, XML has kind of passed me by a little bit. I mean, I get it. I've used it. I understand what it's for. I think it's cool. I just haven't had a lot of opportunity to apply it, and when I have, there have been a lot of performance things that bug me. So again, I'm going to run this and talk ahead a little bit. There we go. But this in particular is a really cool application that at the very least may solve a problem for you, and at the most may really spark your interest in XML again. So before, our problem was needing having detailed information and needing aggregate information. We're kind of going to flip that on its head and say what we really do want is aggregate information. So like the sales order header for each sale. But we also like to see the detail, but on the same row. We don't want 50 rows. See, here we got a whole bunch of rows for sales order ID 61184. And I want to see a list, maybe a comma delimited list of all these things just in one field. Now, how am I going to get that? I'm going to do it with 4XML. Somebody guessed already, didn't they? So we'll run this. We'll see that it can be done, and then we'll go, wow, Jen, how did you do that? Here we go. Here's order 61184 with just the sales order ID, customer ID, and so forth on one row, and a comma delimited list of all the items that were ordered in that order right there in the field. So we have our query here that's not grouped in any way. Here's our header information. Up here we had interjoined on, in the first query we'd interjoined on sales order detail and product to get that full list of detail. We've taken those joins out of the main query, and we've put them in kind of a subquery here under one of the columns. So items equal all this stuff, and it's a select name from product to join on sales order detail, and we've also joined to the outer query here for XML path. Let's take a quick look at how that works, and all will be well. So okay, this is what XML does. It takes a list like this, where you've got one row for each detail, and it packages it up into a single field, one key next to another. Now, we've given this, so select top 10 name for XML path product. That product puts an outer key, or an outer, sorry, what do you call that? An outer tag around our data. And the name of the column itself is an inner tag around the data. If we were to, if we were to say add another piece of data right there and run this again. So right now we've got select top 10 name and then name 2. Now in our XML we see product tag, name, and then another tag name, and then end product. That's great, but for our list we don't want these tags. We just want this detail right here. Well, it's easy enough to take out that product tag. Hang on, backing up a bit. By saying for XML path blank, right? So no tag. Okay, great. We've gotten rid of our product tag. The next thing we want to do then, and I'll type this ahead, is get rid of this name tag. How do you get rid of the name tag? Well, by getting rid of the column name itself. We would have to provide a column alias here for those of you who are a little bit behind, single quote, comma, single quote, plus name, because by adding these things together, it no longer has a default name. Well, that's exactly what we want. We don't want it to have a name. And here we have our beautiful comma delimited list, and we're going to take off that leading comma with